Welcome to the module number 1, lesson number 2, bytecode and Java architecture. In this lesson, the topics that we're going to learn are introduction to the concept of bytecode, the compiler, and so many other things that we have in the bytecode concept lesson. Then bytecode and its dynamics, introduction to the Java virtual machine and the architecture of Java virtual machine, Java runtime environment and its architecture, the Java development kit and its architecture, Java folder structure and how do we use Java folder structure, downloading and installing Java, the JDK 8, the Java development kit 8, which is the latest version that we have, download and start Eclipse IDE, the IDE that we use for Java programming. So let us start with the concept of compiler before we get into the bytecode concept. So what is a compiler? In any programming language, when you look at to convert a programming language code that we write into machine dependent code, or because the any programming language, whatever you write directly is consisting of different set of words or symbols that as a person or as a programmer is what you know. But how does the machine know those instructions that you pass to the machine? For example, if I ask to add 2 plus 2 then and ask the machine to return it, whether it is a C language or a Java language or any language, how does the machine know that it has to return 4 as the answer? So the machine has to understand whatever instructions that are passed to it. So the English language words or any language words that we have will be converted into the machine understandable languages, which is the binary code. Compiler is the component which converts a programming language into the machine understandable language. That's why I have mentioned here a program that translates the program written in source code into instructions that a computer can understand is a compiler. Or compiler is a software used to translate the text that a programmer writes into a format that the central processing unit or the CPU of a computer can understand. Alright, so the programming languages which usually use compilers are C, C++, then Pascal. If you look at the old programming languages, there are so many languages which use a compiler. So a compiler is a program. It's also a program which converts the code that is written by a programmer into the machine understandable language for the machine to give you the output of what you are actually asking. Now coming to the concept of an interpreter. An interpreter is also like a compiler, but it is used in place of a compiler. What is the difference between a compiler and an interpreter? An interpreter is a computer program which can directly execute or say perform the instructions that we write in a programming or a scripting language. We don't need to convert it into directly the machine understandable language, which is we don't need to compile it specifically into machine language program. We can interpret a language into which are a set of instructions into some other kind of program. Okay, which means in an interpreter there is no any intermediate object code, or there is no specific object code which the programming language converts into the machine understandable language directly like a compiler. Instead, every time we have the higher level language, the Java language or C# language or any language that we have the higher level program which is directly converted into a lower level program. It is not the bytecode, it is not the object code or the machine understandable code that the interpreter converts directly the programming language code into. Instead, it will convert the program that we write into a lower level program. So what are the examples that we can take for using interpreters? or the languages that we use, that use interpreters are basic. Yeah, that's the name of a programming language which was used earlier. There is a programming language called Lisp which also use interpreters, and specifically when you talk about Java is the language which use the interpreters. So remember, interpreters convert language source code into a lower level language program or a lower level program. Moreover, in a compiler, the entire program is converted into object code or the machine understandable language code at a time, which means if I have 20 lines of code in a C language program, it converts into the object code or the machine understandable code, the 20 lines at a time. However, if it is a language which converts or which uses interpreters, then interpreter interprets line by line and then converts that each line into the lower level program. That's another major difference that we have between compiler and an interpreter. Having spoken about the compiler and interpreter, now let us look at the concept of bytecode. So what is a bytecode? Bytecode is not an executable code or any exe file that we always look at. Okay, bytecode is a Java proprietary intermediate code, and that bytecode is not a machine understandable language directly, which is something like once you compile any program, whatever the machine understandable binary code which it gets converted, bytecode is not that code which the machine can understand directly. It's a Java proprietary intermediary code, which is once you write the Java code, it gets converted into some intermediary code which is not understandable by the CPU directly. Then what is bytecode? If you look at any other programming language like C or C++, the normal programming procedural languages, then whenever you convert any C language program, for example, say I have a C language program, I write it and I compile it, the programming language converts, or the compiler converts my C program into, it does not convert into any other separate program. It actually compiles my code and checks whether all the lines in the code or in the program are perfectly fine for the syntax and other things, for the logic and syntax. Into machine understandable code it converts, then it will check whether I have the perfect syntax, and then when I run it, it will run for that code, which means there is no specific other file that is generated in any other programming language like the C language. But when you look at the Java language, whenever you compile a Java language program, there is another file that is generated. Say for example, if I have a Java program called myprogram.java, when I compile it, it gets converted into another program, or it generates another program or another file called myprogram.class. Alright. So how is our Java file getting converted into some other file or generating a new file? Whenever you write any simple source code into a Java file or into a notepad, say plain notepad or a text file, and save it as a .java extension file, and when you compile it, it gets converted. After successful compilation, it generates, or the Java compiler will generate a new file which is an intermediary file called .class file, which will contain something called a bytecode that I spoke about. The bytecode, which is an intermediary language before the machine can understand, which means it's an intermediary language which the machine cannot understand directly. It is a lower level program that we spoke about. Alright, So the greatness of the bytecode is that the bytecode generated after compiling in Mac, Windows, Linux or Unix or any other operating system will be the same, which means bytecode is platform independent. So bytecode once compiled in any platform can be executed in any other platform, which means bytecode once compiled in one operating system can be executed in any other operating system. So you would get a doubt mentioning that. So unless any programming language program once converted to machine understandable code, how does it execute? Which means if I write some code and it does not get converted into binary language, how will the machine understand that what it has to execute? You would have that doubt. And we have the answer in something called a Java virtual machine for the Java language. So what is Java virtual machine? The Java virtual machine, I can say it's a hidden computing machine, or it's a virtual machine or an imaginary machine that we have which drives the Java code. It is also like a actual computing machine, or it's like a computer inside a computer, or it's like a small computer inside the Java programming language, which has some set of instructions which can manipulate the Java code that we write. It can also manipulate the memory areas of the CPU for the Java code. Or in other words, it is like a real computing machine which has some instructions set. Those instruction set can manipulate the Java code written and the various memory areas during the runtime. So what is the bytecode and what Java virtual machine does with it? So bytecode is the highly set of optimized instructions designed to be executed by the JVM, or the Java runtime environment, or the Java runtime system, which is an interpreter, and that is called by the Java virtual machine for execution. The job of the JVM or the Java virtual machine is to read the bytecode that we have compiled into of a Java program and convert that into the machine dependent instructions, which is the job of a JVM is to read the low level program that we have converted of a normal Java program and convert that into the machine understandable code, or the object code, or the binary code. So bytecode need not be platform independent, but the JVMs have to be platform specific. So if you look at the basic structure of a JVM or the Java virtual machine, the part from where you compile of a normal Java program into a class program, or once you compile a Java program, the generated class program, till that part is platform independent, because there the conversion or the generation of a new file results with a low level program inside it. So that part is the platform independent part. From the part where the Java virtual machine turns the low level program or the class file of Java into machine dependent instructions, that part is platform dependent, which means it depends on the operating system. So what is the advantage that we have if we have something like this? When you have a Java virtual machine, it will provide greater flexibility for the developers to implement their logic, which is not specific to an operating system but specific to a JVM, which means I don't need to write my Java program or any software using Java which is specific to only Windows or Mac or Unix or Linux. I can write it as a common code, and it can be used in any of the operating systems. So as we already spoke, an interpreter converts each line into machine understandable language. So JVM here is the interpreter for the bytecode. So JVM or the Java Virtual Machine has to be specific to each operating system, and JVM will implement, or the JVM implementation will be different for a different platform or the different operating system, depending on the interpretation that it has to give for the bytecode. Which means the JVM will be different for Windows, it will be different for a Mac, it will be different for Unix, and any operating system that the bytecode has to be understood separately. The JVM will be different for each of the operating system. Let us look at the consolidated architecture of the Java Virtual Machine. In the Java Virtual Machine's internal architecture, we have the bytecode or the .class file, which will go to a compartment which contains a bytecode verifier, interpreter or the just-in-time compiler, and the memory management part which also you have in the same compartment. From there, the flow will go to the machine. So whenever you have the JVM inside it, or the bytecode will flow into the JVM, from there it will go to the compartment containing all these blocks. First it will go to the bytecode verifier and it will check whether the bytecode that has been converted contains enough things that it can convert or it can use. It will also check whether the bytecode is okay, which means it is free of errors or problems. Then it goes to the interpreter or the just-in-time compiler, which can convert things. From the bytecode verifier and through the interpreter, we have direct link to the memory management, where it will check how many objects are being used, what are being used, whether it can scrap anything during the runtime. All the memory management things and allocating memory will be taken care by the memory management compartment or the part of the compartment. From here, the bytecode which is converted into machine dependent or machine understandable language will go to the machine or the operating system, where it has to get executed. We have already learned some time ago that Java Virtual Machine is the runtime system which will convert the bytecode and execute the program. So Java Runtime System is also known as the Java Runtime Environment or the JRE, which is also a physical software. Unlike the JVM, which is a virtual machine, or which is called machine inside a machine, or which is the part inside a Java runtime system, JRE or the Java runtime environment is a software that can be downloaded as a physical division, and you can install it on any operating system like the Windows, Mac or Linux. Why? Because Java runtime environment is the thing which actually will run the Java program once the Java program generates a new file called the class file. And JRE is the combination of the JVM, the Java Virtual Machine, and the Java API, the Java Application Programming Interface. So if I look at a mathematical understanding, JRE is equals to the JVM plus Java APIs plus runtime libraries. And JRE will not contain any development tools like the compiler or debugger, and it is also not for development purpose, which means if you have JRE in your system, you can have JRE in any of the machines, but JRE will not produce any Java code separately. It will intake any Java code and execute that code. That's it. That is the reason in most of the companies you don't find JDK directly in your system. but Java programs will be executed in your systems. The reason is that you have the Java runtime environment in your system. Now look at the architecture of JRE or the Java runtime environment. If you look at that part, we already spoke about the JVM, and because JVM is the internal part of the JRE, you can look at the part where we have the platform independent thing, which is conversion or a generation of a new file from the .java file. From there the data flows to the JRE, which contains the JVM, and it also contains the Java APIs and libraries which are converting the program into machine code, and execution is done there. And the JRE part is shown as the platform dependent part. Now what is the JDK or the Java Development Kit? The Java Development Kit is a set of the development tools which can be installed on a local machine for us to write and compile the Java programs. Compile in the sense for execution. So JDK will contain the JRE, the Java runtime environment, which is used for running the applications, as well as the development tools and some libraries which are required for development. So JDK equal to JRE plus Java development tools plus the libraries. So if you look at the JDK architecture, whatever Java code that we write, it converts the Java code to bytecode entirely, and then inside the JDK we have the JRE and the Java APIs and libraries and the development tools and libraries, which entirely convert the program, or we develop the program using JDK and compile it as a .class file generation and execute it to the machine using the JRE. That's the entire architecture of JDK. As well, we also have JDK as a physical division which we can download as a folder structure. So if you look at the folder structure of JDK, we have a root directory for the JDK, and the root directory will contain a source.zip file, and once you have that downloaded, we have a standard library of classes. If you look at the folder structure, this is the folder structure. From JDK folder, you have a bin folder, a demo folder, an include folder, a sample folder, a JRE folder, and a library folder. Inside the JRE folder, you once again have a bin folder and a library folder. Now coming to what contains in each of these folders. A bin folder of the JDK directly affiliated contains a compiler, interpreter, and other executable programs. A demo folder will have subdirectories which will contain some demo code for us to have an example of different structures or different programming usages. An include folder will have a C header file for native code. So Java programming language actually is written in C program. So it will contain the C header files for its internal code. Then a sample folder will have some samples called JNLP samples. The Java runtime environment JRE folder contain a bin folder and a link folder. In the bin folder, again we will have some executables which are required for the runtime. In the library folder, we have some class libraries which are required for the execution. In the lib folder, which is under direct affiliation of the JDK, we have files that are used by the executables. We have already learnt that Java is actually created by a group of people from the Sun Microsystems. However, at a later point of time, Java has been bought out, or the Sun Microsystems has been bought out by the Oracle Corporation. So right now the Java that we see is from the Oracle and not from the Sun Microsystems directly. And if you have to download the JDK or the Java kit for us to use as a programming language or as a technology, we have to download from the URL of the Oracle website. It is shown to you as the http://oracle.com tech network java sc downloads index.html. We have to go to this URL to download the JDK or the Java Development Kit latest version. You can also download previous versions if you are interested in the previous versions. And during the downloading, once you go to the next page, you have to accept the license agreement, and then only you can download the latest JDK. And if your operating system is 32-bit or 64-bit for Windows, or if your operating system is any other like Mac or any other operating system, choose between the operating system version and the bit version and click on the accept license agreement and download it. Once the download is complete, you have to run the exe file inside the Java Development Kit folder, which will take us to this pop-up. And here, once you have this pop-up, click on the next button and you will be proceeding through a set of pop-ups or set of instructions to press next and install the Java Development Kit. Finally, once you have all the structure or all the flow done, you will get the message saying the Java has been successfully installed, and you can proceed for execution or you can proceed for usage. You have a button to close the pop-up. However, you cannot directly use the Java Development Kit from anywhere unless you set the path variable of your environment variable of the system, which means I have to create a path variable or I have to edit the path variable. If it is Windows, I have this structure where I have to edit the path variable of the environment variables under the system variables, where I have to give the JDK installation directory path if the JDK installation directory is somewhere in the C drive. Usually it will be in the C drive, program files under Java folder, JDK 1.8 or 1.7 based on the installation that you have done. So the JDK installation directory /bin is what you have to give by editing the path variable and giving a semicolon at the end. So I have shown you here from my system where it is for Java 1.8 C:/program file /java /jdk 1.8.0_31/bin. This is the path in my system. We should also set a user environment variable called the class path, which should have the value JDK installation directory /lib/tools.jar. For Java 1.8, the class path will be C:/program files java jdk /lib/tools.jar. Okay, once you are done, you have to restart the PC. Then we have to go to the command prompt and type java -version to get the version of the Java that you have in your system. If you have installed correctly and if you have the class path and the path variable set correctly, then it will return the version number of the Java that you have installed in your system. You can also alternatively type the Java compilation command javac directly in the command prompt. If you get the output with all the instructions that you can use with javac command, then you can say that the Java has been installed in your system correctly. What is the use of installing, or what is the use of adding the path variable and the class path variable to environment variables? If you write a Java program anywhere on your system, say on the desktop or any F drive, E drive that you have, if you want the program to be compiled directly, then if you set the path variable or the class path variable, it will compile and run from anywhere once you have the Java file that you wrote anywhere. Unless you have the path variable and the class path variable, they will not execute or they will not compile and create a new class file unless you have the path variable and the class path variable. However, in academics, we might have written programs or Java programs in text files directly without having any IDEs or the integrated development environments. If you don't use any integrated development environment, inside a text file, you have to write the entire code exactly as it is required, along with hyphenations or along with cap letters and small letters by yourself, and then compile that code and execute. But if you have something called the integrated development environment or the IDE, it is easy for us to write and execute the code because we don't need to write the entire set of code. We have some common generated code or existing code, and we also have help of classes and methods which are already there, can be picked up by the IDE. It will also help us writing the correct code and correcting us by giving the small letters or cap letters based on the requirement for the language. So I'm going to show you and download something called Eclipse IDE, which is the common and industry standard IDE which is used for Java development specifically. We also have something called the NetBeans, which can also be downloaded and installed or used. But Eclipse IDE is the best source which can be used for Java programming. So how do you download Eclipse IDE? We can download Eclipse for Java developers, extract and save it on any drive. It is actually free, totally free. Mostly when you look at Java program, all the resources required for the Java programming language are usually free or the open source tools. Okay, once you download the Eclipse folder, we can run the eclipse.exe file directly on our system. We don't need to directly install anything. In the latest version of Eclipse, we have the option to install. However, in the older versions or in the latest version also, we have an option to just download the folder structure and run the .exe file from the Eclipse folder. For downloading Eclipse, we can go to the eclipse.org/downloads webpage, where we have the option to select the mirror site from where we want to download. So based on the operating system, we can choose the bit version also and choose the Eclipse mirror from where we want to download. Save the zip file that we are downloading onto the disk. Once you have downloaded the zip file, extract the zip file and unzip it, and you can place it on anywhere in your system. By default, it will show us some space. If you want to keep it in the normal or the default place, you can put it, or you can place it in some other place. Once the extraction process is finished, open the Eclipse folder. As I have already shown, once the Eclipse folder, you get into the Eclipse folder, you have a eclipse.exe file which will have a round violet color icon which you can double click and open. Or it is better that you create a shortcut for you to access it from the desktop. So right click and choose send to desktop for creating a shortcut. So what happens once you double click on the exe file, it will open a pop-up or a small window asking for you to choose a workspace. What is a workspace? A workspace is a file where you have all the Java programs that you are going to write. So the folder or the place where you want to store all your Java programs, you have to choose that folder for you as a workspace, or you can create a specific folder in any of the drives in your system and browse to that folder, so that you want to show that you want to store all your Java programs into that specific folder. That will be your workspace. So I would personally choose my workspace because a specific set of programs for any specific project I'll put in a specific folder, and other set of programs I'll put in some other folder in some other place. So I choose my workspace to be at a specific place. Once you choose a workspace, you get directed to a page called the welcome page of the Eclipse. You don't have to do anything in the welcome page. You can't do anything actually unless you click on the right hand top corner icon called the workbench. The welcome page can take you through an overview or the samples or tutorials or what are the new features of this version of Eclipse, but the actual work is done in the workbench. So click on the workbench icon on the right hand top corner to take you to a page where there is a blank package explorer because you have launched the Eclipse for the first time. In the package explorer, you can create project structure of a Java project. You can add packages and then your class files and or any other libraries that you want to add. So this is how an Eclipse IDE would look like for you to program. So that's the end of lesson 2, and thank you.